Right, good evening, everybody. Thank you very much for joining us for the webinar this evening, which is being hosted by AHDB Beef and Lamb and AHDB Dairy. My name is Catherine Parrott, and I'm the Knowledge Transfer Officer for Beef and Lamb within AHDB. I'm delighted to bring you tonight's webinar on improving silage making. Our presenter this evening is Dr. Davies. Dave is Director of Silage Solutions Limited and currently a visiting researcher at Rothamsted Research. So the plan of action for this evening is that Dave will take you through a presentation. That should last between 30 and 40 minutes, and then there'll be some time for questions at the end, and we should finish at roughly 8 o'clock. You'll all be muted throughout the webinar, but if anybody would like to ask a question, or if you think of anything at any time throughout the presentation, then please type it into the box on the right-hand side of your screen, and then when Dave's finished presenting, I can ask him those questions. There's over 320 people registered for the webinar this evening, so I'd just like to thank Elena, who is working behind the scenes to keep everything running as smoothly as possible, and there shouldn't be, but please do bear with us should we encounter any technical difficulties. So without further delay, I'll hand over to Dave for this evening's webinar.
Thank you, Catherine. I'd like to thank AHDB for inviting me to present some information on improving silage making. It's a big subject area. I'll try and give a flavour for various points, and here goes. So I think all too often we are told to move forward, we need to think outside of the box. But I think silage making is a subject where actually there's a lot of information we already have, and a bit like Doctor Who's TARDIS, it's much bigger on the inside, so we really need to focus our attention to the detail of things we know and things that we can achieve to improve our silage making. So first of all, I'd suggest that we should all have a target. And the first target is the quality. And there we need to consider initially what stock is the silage intended for. And all too often I go on farms in the UK where the farmers tell me this is the silage I've got, as though it's almost by accident. And if we have this target, and I would argue that most British farms should have at least 2 silage qualities, high quality for their productive animals and lower quality for dry cows, for instance, whether that be sucklers or dairy cows. That's the quality they need. And if we have a target, we're more likely to hit that target. So what are those stock's nutrient requirements? And then I throw in a third question. What happens if I maximize their nutrient requirements from silage? And there's only positives from this. We reduce concentrate input, and don't forget, ruminants evolved to eat forage. So if we can provide more of their nutrition as forage, we have healthier animals, and actually we can significantly reduce vet bills in many cases. And then we should be thinking secondarily of quantity, inputs, timings, and flexibility. And I'll come back to these things as we go through today's presentation. So first of all, I want to start with fertiliser applications. And this time last year, this would be 4 weeks too late. Maybe this year I'm on time. I'm not going to talk specifically about fertiliser inputs, but I want to make you think about the nutrient offtake when you take your silage cuts. And I'm focusing today on grass silage. So if we consider our target for our high producing animals, be that sheep, finishing beef, or dairy cows, then we should have a crude protein target of 16% or 160 grams per kilogram dry matter. And if we've got a yield, and this is a fairly average yield of 5 tons of dry matter per hectare, then we can calculate how much nitrogen we've removed. Crude protein is nitrogen multiplied by 6.25, so 16% crude protein is 25.6 grams of nitrogen per kilogram of dry matter. And in that cut of 5 tons at 16%, we are removing 128 kilograms of nitrogen per hectare. So I'm not saying all this should come from fertiliser, but it gives us a clue on how much nitrogen we're removing and what we might likely need to put back into that field for a second, third, and subsequent cuts. And the target here for nitrate N, which is a pre-cutting analysis that you can get done, should be that the nitrate N should be less than 0.15% fresh matter, or if that's on milligrams per kilogram of fresh matter, that's 1,500. The second target in terms of protein is sulfur, and in the past we had sulfur for free in rain. Now, more often than not, we have to apply sulfur, and at a ratio of 12:1 in a fresh grass, that's not sulfur limiting. But if we're up at 15 nitrogen to sulfur, sulfur is becoming limiting in that situation, and we will need to apply sulfur in order to get the protein quality we would like. And so using the same above calculation on 5 tonnes of dry matter at 16% crude protein, that's equivalent of removing 10.7 kilograms of sulfur per hectare. So it's just giving you a feel for the nutrients you're removing when you're taking your silage cuts. I'd now like to move on to the constituents of fresh grass, and this is a relatively old review written by David Beaver in 2000 and colleagues, and it shows how grass changes in the field during growth. And if we look at the left-hand side on the bottom there of that axis, we can see it's 78% D, and if we move to the right-hand side, it's 58% D. And that represents the two extremes of silage making, the dry cow and the high-producing cow, or other stock. And we can see as we go from the left-hand side to the right-hand side, the fibre fractions, the neutral detergent fibre, NDF, which is the hemicellulose, cellulose and lignin, are increasing. The proteins are decreasing, oil is decreasing, or the lipid fraction, and sugars are increasing, and your ash is decreasing. So I would argue that for your high-producing cow, your pregnant ewes, or your finishing beef cattle, you want to be approaching this left-hand side of this screen rather than the right-hand side. Whereas with the dry cow, you need to be nearer to the right-hand side. And the problem with this change in time is that the lignin is increasing, it's binding to the hemicellulose and cellulose, so your D value is dropping. And so that's something I'd like you to bear in mind throughout today's presentation. I now move on to some data. Again, it's old data, 20 years old, from SAC Auchincruve. And it looked at what they considered two cut system, an early cutting and a conventional cutting system. You could make the early cut what we're these days calling the frequent cutting system. And you can see there that the ME on that first and second cut of that early cut system was 11.8 and 11.4 for the second cut, whereas the conventional cutting, a longer time delay between cuts, 11.1 and 11.3. Now, I would say that conventional cutting was still very good in that situation, but many farmers tell me they can't afford to cut early because they won't get the yield they need to supply the nutrients, the silages they need throughout the year. But actually, if we look at the second line, the yield there in tons of dry matter per hectare, okay, there's a knock on the first cut because you've cut early, but by the second cut, you've more than made up for it. And this is because the grass is still in a vegetative state when it was cut at that first cut, and actually it's ready to spring back into life and grow more rapidly. Recovery times are shorter. The other reason why farmers say that they don't want to take that early cut is it's more costly. Well, actually, this again is a bit of a misnomer, because if we consider the yield on the second cut, conventional cutting, it's significantly lower than the second cut on the early cut. So over the two cuts, you actually have a greater yield from our early cutting system than our conventional cutting system. And this follows through in terms of energy yield, megajoules per hectare, and potential milk yield litres per hectare from forage. So when we take that all into consideration and we use a standard contracting cost of £131 per hectare, actually our costs of silage production in terms of pence per litre are lower where we have that early cutting system compared to the conventional cutting system. And if we consider this yield effect of this rapidly or early cut multi-cut system, it's just the same as when we buy our grass seeds and we argue with the seed supplier that there's no way I can get the yields that you're saying you're getting with your varieties. If you consider what they're doing when they're doing their work in the field, they are cutting very frequently, this 5 week regrowths, and that's how they're maintaining these higher yields. So why not do the same in the field for your high quality silage? A week's delay in cutting at first cut, there are a number of consequences of this. Firstly, yes, we will have a yield benefit, up to 10% more, but our digestibility and our metabolizable energy are dropping all the time. And something we often don't consider that we have higher field losses due to that heavier crop. Heavier crops, we have limited weather windows, increasingly limited weather windows with the way the weather patterns are going. So we have a limited time to wilt that crop, yet with that higher yield, we're actually having a more problematic wilting time, and we're having higher yield losses. And like I said earlier, there's a slower regrowth, so actually we get a lower annual yield. So just moving on, often there's a lot of debate about what the ideal percent dry matter is for our grass silages, and there's a lot of misinformation about this. Now this slide is actually very old, it's from the 70s, but things haven't really changed that much. And on the left-hand vertical axis, we have the percent dry matter of the crop in the field or the silage. And on the horizontal axis, we have the dry matter in grams per kilogram. So 250 representing 25% dry matter. And we can see here, as the losses, as we make a wetter crop, our losses are higher. And when we make a drier silage, our losses are higher. So we need to be somewhere in the middle, and the optimum dry matter for our dry matter losses is somewhere around the 30% dry matter here. And there is some people promoting these days the system that they use in the Netherlands with a higher dry matter silage up to 35–40%. But actually, when you have that system, you have higher field losses during the wilting process, and you have a much greater risk of aerobic spoilage at feed out heating of your silage. Whereas on the other extreme, some people say they cannot make their silage drier, where you're making it wetter because it's the water in the liquid phase of the crop that is carrying out the fermentation. The more water, the more fermentation you need. And when we have fermentation, inevitably we have losses. Also, you have the higher risk of effluent there at the lower dry matter. So I'd say the target for most British farms making clamp silage would be 30%. If you're in a bale system, yes, I'm quite happy if you go up to 35 or even 40%, providing we can have a rapid wilt. And often these losses are invisible, and I think it's something that AHDB had a seminar some time ago on silage losses, and farmers don't believe they have them. If they see perfect quality silage, they think they haven't had losses, but unfortunately all farms have losses during the silage making process. So I just want to highlight some issues around this, and I'm using here a cost, as I'm showing here, of £100 per tonne of dry matter to make that silage. Now this is quite a low cost. I think AHDB figures are £120 per tonne, but it makes the maths much easier to work through. Now, if we go over here and you have 10% losses and your costs of production are £100 per tonne of dry matter, then after we've considered those 10% losses before that silage reaches the animal, then our cost of production per tonne of dry matter is £111 per tonne. Many farms will have 20% losses. Probably 50% of farms have got somewhere approaching 20% losses. And here, our cost now has increased to £125 per tonne of dry matter. And I'd say that around 10% of farms have probably got 30% losses or greater, and their costs of production are £142 per tonne. This is in clamp silage. The best you can ever do is probably 10% losses in a clamp. Now, just to talk briefly about bale silage, we know that bale silage losses are considerably lower in general, and that even your average farm can get 10% losses within a bale, whereas your better farms can easily reduce those losses to 2 or 3% dry matter losses. And this is where the cost of producing bale versus clamp become much more similar. Okay, the cost of producing the bale in the first place, the cost of harvesting can be higher, but due to these losses, they can become a lot closer in terms of cost of production. So where are these losses coming from? And here I've got a pie chart, and you can see from that pie chart that we have losses at every stage of the process. And some losses are unavoidable. We will always have some field losses, but we want to minimize them. We will always have some fermentation losses, but again, we want to minimize them. It's surprising in harvesting for silage clamp, how much of the grass never ends up getting into the clamp, blowing away in the field in the wind, or falling off the edges of the trailer. Then effluent is one of those losses that we can actually completely eliminate. When we hit 30% dry matter, there should be 0 effluent. And aerobic spoilage, again, is something that we should be able to minimize. But unfortunately, it was one of the biggest problems on most farms globally. And losses in excess of 10% is commonly seen where that silage is heating up at feed out. So just moving on, I want to talk about some of those field losses. And here I've got an example of some study I did on a local farm to me near Aberystwyth. It's a sheep farm that feeds clamp silage, self-feed clamp silage, excellent farm. And here I monitored the dry matter in the field, took an oven down to the farm, and we took samples from the point of cutting here at 0 hours, and we measured the dry matter at various points from exactly the same point in the different fields in the swath, and right through to harvest time, which was approximately 26, 27 hours later. And there, at that point, it was 38% dry matter. He mowed, started mowing around 11 in the morning, and he started picking up the following afternoon. Now, I would say he'd overdone his target for clamp silage. He should have been harvesting a little bit earlier. And I really want to put this into context of the losses. So what we also did was we looked at the sugar content. And in the field, as soon as you mow that crop, the sugar is disappearing. You're producing carbon dioxide and water, predominantly by the plant's own enzymes that are still respiring, but also by the undesirable aerobic microflora that sit on that crop and increase in number. And by increasing the wilting time, you're increasing the loss of sugar, but you're also increasing the undesirable microflora on the crop, which is then challenging more your silage fermentation and feed out process. So a rapid wilt is essential. So in this field, at mowing, the farmer had 22.9% sugar in the standing crop immediately before mowing. Then by the time he picked it up, and this sample was taken from the sward just before the forage harvester came through, and it was 18.7% sugar. So that represents a 4.2% loss in sugar. And that sugar had vanished to carbon dioxide and water through respiration, as we can see here in that red bar. Now, if you take your mind back to the Beaver et al. Slide at the start, what's happening is that on our analysis, we don't see this carbon dioxide and water, but the other fractions within there, in particular the ash fraction, but also the undigestible fraction, the lignin fraction, and the undigestible cell wall fraction have actually increased proportionally. So we have more undigestible material within our grass at ensiling than we did in the grass standing in the field. And when we looked at the D value of this, it had dropped by a similar amount to the sugar drop. And in terms of mowing and forage harvesting, that was a 4.2% drop, representing almost 0.7 megajoules of energy per kilogram of dry matter. So really, in terms of wilting, what I'm saying is mow when the sward is dry, mow with it spreading as wide as possible with a mower conditioner, particularly with your grass, and then go through it once with a tedder, that's maybe 3 or 4 hours later, to try and improve that speed of wilting, and then have a maximum wilting time. And an absolute maximum to me is 36 hours, but I would prefer it to be as short as possible so that we can retain more of those nutrients within our silage rather than letting them disappear into the atmosphere. So now I want to talk about dry matter losses, and up to this point everything I've said is relevant to clamp and bale. I'm going to focus a bit more attention now on clamp. And this graph, or this table, shows some data from America, where they carried out a survey of around 35 farms. They measured the density in kilograms of dry matter per meter cubed within the silage clamp. So here we had poor density at 160, right up to good density at 320. This is excellent density. And alongside that, they measured the losses associated with the relevant densities. And they showed that with the poor density, 20% dry matter losses, compared to the good density, 10% dry matter losses. And this situation is similar to that in the field, where you have poor density at the start of the preservation process. You actually have air, oxygen, so the sugar is still being respired to carbon dioxide and water, and it's not producing acid. But more importantly, that poor density enables some bacteria that can actually grow anaerobically without oxygen and aerobically with oxygen. They increase dramatically in those first few hours of fermentation, and they can then carry on growing when it's anaerobic, and actually their efficiency of fermentation, they're producing other end products that aren't acidifying the crop so quickly and producing more carbon dioxide and water. And this is why clamp density is so important. So January 2017, I was lucky enough to receive a grant from AHDB Beef and Lamb, and thanks to Liz Jennifer for supporting me in this. And there are the farms I visited, 20 farms across England, and you can see each of those farms going from Cumbria all the way down to Cornwall. And during this survey, it was a clamp silage survey, I took a number of measurements. In particular, At each silage clamp open face, I had 9 sample points, as represented here by the X's, half a metre from each sidewall, top, middle and bottom, and then one centrally, with the top 3 samples being half a metre from the top sheet. And you may think there's too heavily a focus on the half metre within the peripheral regions of this clamp, but that was planned because one of the topics was to measure dry matter losses, and that's the most vulnerable zone in your clamp. And as part of the process, there was a long list of questions and a lot of measurements taken, and we measured every clamp. We measured each dimension, the vertical and the horizontal, and the average of those 20 farms had a height of 2.5 metres and a width of 12.8 metres. And from that, I calculated how much of that volume of that silage was within half a metre of the wall or the top sheet, and the average clamp is 26% of the silage is within half a metre. Now, this is the area that farmers tell me, oh, I've only got a bit of waste on the side, it's not important. It adds up to a significant proportion of your silage. It's also the proportion of the silage that ends up in the mixer wagon or being fed that probably isn't analysed in that sample that's taken by the person that takes the samples for your analysis, because it's just that bit at the side. But that's probably the bit that's messing up your feeding, or at least contributing to that feeding being less accurate. So I said we had a target density. I measured the density at each of those points. So this graph represents 20 farms, 9 samples per farm, 180 samples. And the target density, this is now along the horizontal axis with the number of samples in each density classification at the vertical axis there. And our target on a fresh matter basis is somewhere around 700. So looking across all of those samples, 20% of the samples had less than 400 kilograms of fresh matter per meter cube. 33% of the samples had less than 500 kilograms per meter cube. So you can see a significant proportion of the samples are not hitting my very stringent minimum target. And that's where we're getting this increase in losses, but also this reduction in quality due to those losses being the most nutritive part. Now, behind this, there's a whole heap of data on farm by farm. This is a bit of a horrendous graph. I put it up just to show you that each farm is represented there, F1 to F20. And what I've done is there's 4 bars for each farm, and we can see that the blue bar is the mean of the top 3 samples, the orange is the mean of the left-hand side, grey the mean of the right-hand side, and the orange or the yellow mean of the middle. And we can see in general that the central sample is a lot denser, whereas around the edges there's problems and on the top there's problems. But this is making up a significant proportion of your silage. If we just consider farm 1, we can see that most of those samples are actually pretty close to the target. Farm 2, none of them are reaching the target. So there's massive within farm variability. So there's a lot of data there which you'll be able to read about on the AHDB report when it's put online. What I would like to focus on is actually the difference in density between the left-hand side and the right-hand side. So here we have a graph that shows that 5 of those farms, farm 3 for instance, 13, 16, 19, they have a big difference in density on the left-hand side compared to the right-hand side. And this focused my attention on what was happening. And often you see on farm that the loads of grass are tipped at one side, which is probably restricting access, meaning that the layer depth along that side is thicker as that grass is put into the clamp. Or secondly, it could be that farmers are rolling their clamps in one direction, so driving up the clamp and then reversing down the other side. And what happens then is that they can probably see the sidewall much better through one window than the other, and so they're getting closer to it. And this again is costing us money and causing variability in silage quality across the clamp face. And I was on one farm where I showed this density issue, one side to the other, and he actually turned around and said, yeah, the cows don't eat the silage on the right-hand side, and that's where it was least dense. We have more undesirable fermentation products, and so the intake was falling whenever they were fed that side of the silage. But he was an observant farmer. I bet many of you don't see these things because you're not paying that attention to detail. So I said about maintaining high density during silage filling, and it's a very difficult challenge. So I just want to take you through some simple maths. And what we say in research is that you should have a 15 centimetre maximum layer depth when you're filling that silage clamp. Now, if you take a fairly standard trailer, this is a twin axle silage trailer, and it's got the dimensions 2.7 metres wide, 4.7 metres long, 2.4 metres high, giving a total trailer volume of 30.5 metres cubed when you multiply those three together. I said the ideal filling depth was 15 centimetres. So using a loading shovel, 3.1 metres in width, and you can measure your own loading shovel, then you can do the calculation, and for every trailer load coming in, that trailer should be spread a length of approximately 67 metres to get this 15 centimetre layer depth. So it's just showing where you need to be in terms of that, and it's something you could relatively easily monitor to ensure you're getting that good density. Now, I've talked a lot about clamp. Bale density, silage density is just as important. And where we have a high density, as in this trial carried out a couple of years ago, we had a high density bale, 2% dry matter losses between harvesting and feeding. And because of that high density, we controlled the yeast population during the early stages. And actually the aerobic stability, that was fed out like a silage clamp, so looking to feed across the face, and it had in excess of 10 days before any sign of any heating occurred. So just like my good friend Shreen Vachen would say, in terms of bale density, we need high density bales, we need square edges so that we can wrap that bale properly, and ideally the net or the film that's holding the bale together comes to the edge of that bale, or preferably just a little bit over the edge, so that we can reduce the oxygen within that bale, reduce trapped oxygen, and improve silage quality. So moving back now to the AHDB survey work from 2017, this was one farm that was studied. Each sample of those 9 samples was analysed individually for its chemical analysis. And like I said, many things were studied. I just put 5 analyses up here from 5 points, and you can see where they are. And just looking across them, we can see we've got a range of dry matter from 18.5% to 26.4%. I'll say that this particular silage clamp was one of the least variable I attended in that 20 farms. So there's an 8% difference in dry matter. There's over a 1 unit difference in ME, and quite big differences in crude protein. I want to draw your attention to the sample in the top left-hand corner. Looks quite good in terms of the visual context there. But the one thing I want to draw your attention to is this pH, 7.9. And this was done by wet chemistry, the pH value, not by NIR. And when I looked at that, I thought, what's going on here? And I walked on top, and here is top waste. And top waste should be an avoidable part of the process. It's costing a lot of money. And the sheet had been pulled back maybe 1.5 meters. Typical day in England, raining in January, washing through that top waste. Some farmers think it's protecting the silage below, but actually the ammonia, the protein breakdown products, and potentially clostridial toxins, and even maybe mycotoxins are washing through that silage and actually contaminating the silage below. So this pH doesn't represent the pH that was in that silage during the preservation process, but probably contamination from that top waste. And the other reason why this top waste is expensive is because we can do an analysis and we can measure the ash content. So the ash content in the bulk of the silage in that clamp was 8.9, whereas the ash content in that top section was 15.3 in that top waste. And by calculation, we can calculate how much that ash has been concentrated by the losses. And for every, so within this silage clamp, that top waste had 41% dry matter losses. So if we look at it in another way, 1 kilogram of waste would have weighed 1.69 kilograms if it had been this quality. So even if you weigh your top waste, you're still underestimating the amount of waste you've actually had. And the biggest problem here was the fact that there wasn't enough top waste placed on the top of that silage clamp after filling. So the green mesh, if used incorrectly, so it's flat and it's not tightened up, needs as much top waste as your standard silage clamp, your silage would, your normal sheeting. So just looking again at that particular silage clamp and looking how much that variation in dry matter would do, the variation in NE. Because of our variation in dry matter, we're feeding different levels of dry matter of silage going from 11.8 down to 8.3. And we can see there that our yield, potential milk yield, 8 litres per cow difference depending on where in that silage clamp that silage has been fed from. And this is driven by variation in the field, but also variation in that silage clamp due to these differences in losses. Now this is an extreme because it was just a cord sample. When you take enough for a mixer wagon full, the differences will be less, but they are still significant in terms of feeding animals. So now I want to move on to silage additives, and understanding silage additives is a bit like looking at a plate of spaghetti and trying to decipher which two ends of the spaghetti actually join. And often, just like that plate of spaghetti, you've got to do further investigations to actually define what you need to know about silage additives, and it's not always easy. So, a few facts about silage additives. They are the icing on the cake. If you're making poor quality silage, you're not managing it right, the silage additive will not cover up those problems. They can make a good silage better, but they will not make a poor quality silage into a good quality silage. And the first thing you need to comprehend is the number of bacteria that you're applying per gram. So this was a study I did again 4 or 5 years ago. It took an additive, this red one here, which was claiming that they only needed 100,000 lactic acid bacteria per gram of fresh forage to carry out a good fermentation. And we've known for years in the UK that we need 1 million. There's plenty of research. So I took their product and I actually applied it in the green line here at 500,000 per gram and in the purple line here at 1 million per gram. And you can see a significant difference in the pH decline over those first few days. And the quicker we get that pH decline, the better our silage quality is, because we're stopping the degradative process in the silage clamp. Now you might see that the untreated silage was poorer than even the low rate inoculant, but the reason why this was so slow was this was one of those high dry matter silages. It was above 35% dry matter. When we have a longer wilt to get the dry matter up, we actually kill the natural flora on the crop. And so this needed a good level of additive to get the fermentation going, because we'd inhibited or destroyed the natural flora. And why do we need 1 million? So this is a little bit of a complicated table, but if we take our 1 million bacteria, and most additives will double in number every 30 minutes, most lactic acid bacteria, when they're on the crop. If we say after 30 minutes, then that 1 million is now 2 million. With a 500,000 application rate, or 5 times 10 to the 5, it takes an hour to get to our 2 million. If we're down at 100,000, which some inoculants are, it takes 126 minutes. Now, the difference between 30 and 126 minutes in the lifetime of the silage clamp may not seem like a lot, but we need to add another column, because here now I've got that 1 million. After 30 minutes, it's 2 million. If we just look down to the 100,000 as our example, by the time it's 126 minutes to get to our 2 million, the bacterial rate where we applied 1 million has now become 18 million. So we've a much bigger army to fight against the undesirable population and preserve that crop. And that's why, under UK conditions, wet and overcast, we need 1 million bacteria to speed up that process. And when you start with 1 million, you're always ahead of the game. You're more likely to get a better preservation. Within that silage fermentation, what we're trying to do is control the undesirable fermentation process, or the less efficient. So we have a number of less efficient processes, and unfortunately, and for me it's unfortunate, the heterofermentative lactic acid bacteria are becoming very common as silage additives because they have potentially some benefits in terms of aerobic stability, but we can manage aerobic stability in a different way. So the heterofermentative has a mix of end products, that's why it's heterofermentative. The homofermentative inoculants, they just produce lactic acid. And when you produce this acetic plus lactic, you also produce carbon dioxide and water. Just like that plant respiring in the field at the beginning, you're therefore decreasing the digestibility of your silage. More importantly, maybe, are the enterobacteria that also produce end products, CO2, and undesirable end products. Ethanol doesn't acidify the crop, so you have a slower fermentation. Acetic acid is not as strong an acid as lactic, so again there you have a slower fermentation. And then worst case scenario, saccharolytic Clostridia. They take glucose or lactic acid and they produce a lot more carbon dioxide and water. And wherever we see this CO2 and water, we're not only having dry matter losses, but we're increasing the undegradable part, of the undigestible part of our silage. So just a quick run through of one experiment. There are plenty of experiments that have been done and published in the literature looking at homo plus heterofermentative inoculants. L-plantarums are homo inoculant only, and chemical salts, and this is a new age acid, if you like. And this study I conducted in the summer of 2017. I'm still analysing the results. Chemical analysis was opened after 90 days. And this is the percent dry matter losses. This is small scale, done in Kilner jars in the laboratory, 3 kilo Kilner jars, and we can measure the losses. So with that heterofermentative, homo heterofermentative process, we had around 1.2, 1.3% higher dry matter losses than the homo fermentative and the chemical salts. You wouldn't see this on farm, but what you might see is the difference in the percent dry matter of your crop at harvest and that in the silage, because one of those end products is water. So we're producing water in the silage clamp. And in this study, the homo heterofermentative started out at just above 33% dry matter, finished off at 30.5% dry matter. Whereas the homo fermentative started at the same dry matter, finished about 1.5 percentage dry matter units higher. Unfortunately, the chemical salts, I actually started with a higher dry matter. Even in my Kilner jars, I couldn't control the wilting process as they were all identical. But again, you can see the dry matter hadn't changed so much as where we had the homo heterofermentative inoculant. So moving on, like I said earlier with the grass in the field, we're concentrating the NDF and the ADF fractions when we're having these higher dry matter losses. And so you can see, again, higher NDF, higher ADF with the homo hetero compared to the homo alone and the chemical salts alone. And within that ADF fraction is the lignin. So we're reducing the digestibility by this poorer fermentation. I'm aware I'm running out of time, so I'm going to skip that slide. I'm going to move on very quickly to aerobic spoilage. And the main challenge for aerobic spoilage, the main control point, is the silage clamp at filling. So good consolidation, which I've given you a lot of clues about. And I'd rather have a clamp like this clamp here in the background compared to this one in the foreground. The losses here must be in excess of 30% dry matter, whereas here they're probably less than that 10% dry matter. And stability is good. Now, the only negative aspect of the homo fermentative inoculant is that you preserve more nutrients in that silage, so it is more likely to be aerobically unstable. So you need to make sure you're on top of your clamp management. Density, good sealing, and good top weight, and then followed by good feed out management. If we can do that, we can reduce the chances of that aerobic spoilage. But if you still feel you need an additive to improve that aerobic spoilage, then I would prefer, rather than using the heterofermentative inoculants, you use the homofermentative inoculants in combination with chemical salts like sorbate and benzoate, or you went the whole hog to a chemical-only product that would not have those negative effects on that fermentation preservation quality, and therefore reduce the potential of your silage to fulfill more of your nutrient requirements. So just in conclusion, clamp and bale management are crucial. The walls, the top, the peripheral region of your bale, 70% of your bale, silage within your bale, is within 20 centimeters of the wrap. So again, the wrap is crucial in that system, and that's all about reducing oxygen. Compaction to remove it at the start, and sealing well to keep it out once it's out. And then crops quality at the start. Harvest the quality the animal needs. Assess those nutrient requirements, assess how much quality of each silage you need, and then reduce the variability in that silage clamp by silo management, which comes down to the things I've said, compaction and filling, but also look at that variability in the field. If we make these early cuts, more of the grass is in the vegetative state, that means we've got less going to head, more likely for that forage in the field to be coming in the same quality into the clamp, and so being able to maintain consistent silage throughout the feeding season. Thank you for your attention. and I'm sure Catherine will now be asking questions on your behalf.
Brilliant. Thank you very much, Dave. Whilst I'm just waiting for some questions to come in, I'd just like to remind everybody of a couple of things. Firstly, Dave made a reference to a webinar on silage losses that was hosted by AHDB Dairy and is available on their YouTube channel if anybody would like to have a look at that. And then also we have a number of resources that may be of interest to those of you listening. So firstly, the recommended graph and clover lists document is available on both the dairy and beef and lamb AHDB websites. And then there's also a few manuals on the beef and lamb website for making grass silage and growing and feeding maize silage that might be of interest to you. So Dave, the first question I've had is, we farm a prime suckler beef herd aiming to finish house cattle off conserved forage with a little supplementation for energy. The weather windows to make silage are getting shorter, and the last couple of years, the first and third cuts were both delayed by wet weather. What advice would you provide on relevant techniques and technology to help us conserve the quality, please?
I suppose the first part of my answer will be that if you make more frequent cuts, your yield is lower. You can actually wilt that more quickly with these ever decreasing weather windows, and maybe you can hit the target better because you need less time to wilt that lower volume. I also think that, and I judged the All Wales Big Bale Silage competition, there was an excellent farm this year that did very well. They are a system that sounds similar to yours, and they've gone over completely to bale silage production. Now, if it's possible, then within your system to do that, it gives you more opportunity to take fields out one at a time where that weather window is limited, and it's not such a big gamble as it is with a clamp with these where you need the whole of that harvest in one day. So those would be my two quick ones. Obviously cutting height has an effect on wilting speed, so if you do leave a 5 or even a 7 centimeter stubble height, your grass actually rests on a bed of stubble, which means that the air gets underneath it, and again the wilting time is quicker. But I know it's one of those major challenges, and I find year on year the farmers that manage to harvest early in their first cut tend to always be ahead of the game in terms of those harvest windows. But every sympathy. I can't control the weather. None of us can.
Okay, and then we make bagged square silage and use contractors to bale and wrap. Is there an issue with the application of additives for them, as none of the local contractors seem to use them currently?
It's a major problem with bale silage is contractors not having applicators. They are available. It's a decision that somebody has made not to put an applicator on the baler, that they're perfectly available. What I would say with all applicators, but particularly in bale and forage wagon silage, is make sure that when you fit that applicator, you've got enough spray nozzles on it that are spraying onto that forage, closely onto that forage, so that you're spraying the whole width of that forage. But there's no reason why you can't be done. And if you really think an additive is going to be benefit to you, if you're making top quality in bale silage, then there is the option of going along in front of the baler with a ATV sprayer and spraying it on the swath in front. What I would say, if you do that, make sure that the sprayer is set low enough to the ground that it's spraying the swath, not the bare ground between the swath when the wind blows.
Okay, thank you. What are your thoughts on tedding after mowing?
Tedding after mowing is very good, so long as it's set correctly, and many aren't. Many are dragging the soil into the crop, so set it correctly. In terms of wilting, the maximum wilt time is when the stomata on the leaves, the pores on the leaves, are open. When they're open, you lose 100 litres per tonne per hour. When they're closed, it drops to 20 litres per tonne per hour, and they only stay open for 2 hours after cutting. So if you spread behind the mower and you've got a wide spread, then it's not quite so essential to get in there as quick as possible. But if you're leaving it in a narrow swath, it's essential to get in there straight after the mower to improve that wilting time, speed of wilting.
Okay, thank you. What are your recommendations on the perfect cut for baled silage? There's quite a lot of variables here that they're asking for, but in terms of dry matter in the sward and in the bale, the time of cut, length of wilt, and then tedding and baling time?
So the targets for bale silage, bale silage should be as good as clamp silage. It should be what you want. So my targets are very similar to my clamp in terms of cutting time. Ideally, a wilt for me on a bale, you need to be hitting 35, ideally 40% dry matter, but you should be doing that within a 36-hour window. If you can't do it within 36 hours and you need 3 days, then that's too long. You've lost the quality. So the only thing I change between bale and clamp is the dry matter. The advantage you've got in a bale, because you're wrapping it quickly, you have less losses during fermentation and significantly lower losses during aerobic spoilage of feed out, providing you look after the wrap. So, I'd say it's exactly the same process as a clamp, and your best bale silage will be better than your best clamp silage because you actually retain more sugar in that fermentation phase because it's not as extensive. But it's really about speed of wilting. And so, yeah, ted twice if you can afford the time to do that. Tedding twice in bale silage will increase that dry matter up to that within that target window.
Right, okay. Should any allowance be made in nitrogen application when taking earlier cut?
Yes, it definitely should. I'm not a fertiliser expert. We tend to use 2.5 units per day as the maximum units of nitrogen a grass can incorporate into quality protein under ideal conditions. In the past, I've always advised no more than 2 units per day. Unfortunately, over the last 10-15 years, crude protein contents in silage have been dropping, and I think a significant part of that is lower nitrogen applications either in fertiliser or farmyard waste. So I think if you are going for this frequent cut, one thing you do need to do is monitor that nitrogen application. I would recommend you do a pre-cut analysis to assess where you're at with that nitrate versus crude protein, and to adjust your subsequent fertiliser applications on those fields. I say that because I think it's the best gauge you've got at where you were at with that fertiliser application. And each field and even regions within fields will be different. So if you go around the headlands, it's probably going to have a lower efficiency of nitrogen utilisation because it's more in the shade, more often in the shade than the centre of the field. So there'll be variations across the field as well.
Okay, great, thank you. Somebody else has asked, would you recommend that we buy silage compactor?
Well, that's a bit commercial, isn't it? I have to say that I travel a lot. The Czech Republic use the silo compactors. They've been using them for 30 years. The clamp I showed with the ideal quality just here, this one, this is a clamp from the Czech Republic and shows how compaction during filling helps to maintain a good quality. So the compactor does have a massive role to play. The advantage you've got with it is not the 4 or 6 tons, depending on which one you buy. It's the fact that you're consolidating a whole tractor width in one go, which means that in terms of keeping up with the appearance of fresh trailers of grass, you can move over a whole tractor width, so you can maintain good compaction and speed of filling. So that to me is the big advantage. It's not the weight, it's the fact you're compacting more of your forage at any one time.
Okay, lovely, thank you. How do you know when the wilting process is complete prior to foraging or baling?
There is within the AHDB, or the Beef and Lamb Good Silage Making Guide, a quick and simple and accurate method that you can squeeze a grass by hand. I'm not going to go through the variables. It's in that AHDB guide, which is on the web. If you're listening in Wales, it's in the Heavy Key Cymru guide. Ideally, you can do a dry matter in the microwave, which is pretty accurate. So you put 100 grams in the microwave, dry it slowly, or heat it slowly, weigh it out. When the weight is constant, when it comes out, that's your dry matter. But that's a slightly more long-winded process. And if you do use the microwave approach, I'll keep an eye on the microwave the whole time, because as it gets dry, it will go on fire if you're not careful.
How do chemical salts differ? How do the chemical salts differ from bacterial inoculant or acid additive in mode of action?
So the inoculants promote fermentation through the use of the inoculant bacteria. The chemical salts are more similar to the acids of the past, so the formic acid and the propionic acid. The sorbate and benzoate within those salts inhibit the yeasts and molds. Some of them have nitrite, sodium nitrite, which is used in the production of bacon, for instance, and that nitrite inhibits the enterobacteria and the Clostridia. So the mode of action of these new generation salts is actually to inhibit the undesirable microflora and allow the good beneficial lactic acid bacteria to control that fermentation. And the advantage of these salts over the acids of the past is that they are completely safe. They're all food grade preservatives. So they are inhibiting the undesirable population, allowing the natural population of lactic acid bacteria to dominate that fermentation more quickly.
Okay, thank you. What's the best type of additive for third and fourth cut red clover silage and the optimal dry matter? For red clover silage and red clover mixed with grass, you've got a positive in that because of that clover content, and it's possibly down to the protein content, but it could be some of the other salts in there, that actually the preservation process inhibits or makes that silage more aerobically stable. So you've got less challenges in terms of aerobic stability. So in that situation, you should be thinking about the preservation fermentation process more than aerobic stability. The disadvantage of a clover is that it's low in sugar and high in protein, which makes it difficult to ensile. So for that sort of crop, your target dry matter should be minimum 30, ideally 32, 33, and I'm quite specific on these. If you go to 35, you're actually going to increase your chances of leaf shatter and leaving protein in the field. So for that preservation, you either need one of the chemicals, and I've nothing against the acids, but like I said, the new salts are also beneficial, or you use one of the 1 million bacteria homofermentative inoculants, such as Lactobacillus plantarum in a number of these. And there is plenty of trial work with those types of products showing that they will preserve that crop in adequate condition. Okay, thank you. Do you have any tips on minimising slurry contamination in silage when using a frequent cutting system every 4 weeks? Cutting every 4 weeks, that is.
If you're cutting every 4 weeks, you must not use a splash plate spreader. You must put it on the surface of the ground, or preferably injection, because that's the only way you can reduce that surface contamination. And it's sod's law. It's the one thing that happens when you put slurry on and you're in that frequent cut system. You have a dry period and that slurry grows up with the crop. In that situation, it's 1 gram of slurry will contain 1 million Clostridia, and Clostridia produce spores which are quite happy when it dries out or gets wet, and they'll survive right the way through into the silage fermentation. So if you're on that frequent cut system, it's one of the situations, and you're spreading a lot of slurry, which I know some dairy farms are, then you need to consider the chemical approach, because where you've got a high slurry contamination level, you can't always guarantee that even the best silage inoculant homofermentative will carry out that good preservation process. And to guarantee it, the chemical will, because it will inhibit the Clostridia directly, rather than waiting for the fermentation end products of the inoculant to do it.
Okay, thank you. What do you recommend in terms of the time of day to cut?
That's complicated, because we always used to say cut in the afternoon, the sugar's higher. But as I showed in some of my early graphs, we actually lose sugar during the wilting process. So the longer you're wilting, the lower the sugar. So if you've got ideal weather conditions and you can cut at 10 o'clock in the morning, and your contractor's waiting by the gate for you to say go, and you can pick up at 4 o'clock in the afternoon or 5 o'clock, then your sugar will probably be higher than if you cut at 2 o'clock in the afternoon and wilted for 24, 36 hours and got to that ideal dry matter, you're likely to have lost the sugar benefit from cutting in the afternoon. However, if it's an early cut, weather's not so great, then cutting in the afternoon to hit that target of 30% dry matter the next day is much better than cutting first thing in the morning and making a wet silage. Because there's three variables: the dry matter of the crop, the wetter the crop, the more sugar you need for the fermentation, the speed of wilting, and the sugar content at the point of cutting. So there's different things for different times, different harvests, and different weather conditions. No straight answer, sorry.
Okay, thank you. When cutting fields individually rather than all at the same time, it's difficult to decide whether to cut when they are at optimum quality and run the risk of spoilage by opening the clamp repeatedly. What's your thoughts on that?
I really don't like the clamp to be reopened. I think doing it once for a first and second cut is just about, you're just about able to get away with it. If you're going to open it every 10 days or every week, then that can be a disaster. And the reason I say that is that carbon dioxide is your first silage additive for free. You always get carbon dioxide in your clamp. Even if you're doing the best conditions, you will get some CO2. CO2 inhibits a lot of the undesirable processes. As soon as you open that clamp up, that CO2 falls out. It's heavier than air, so it falls out of the clamp and oxygen sucked back in. So you restart the undesirable flora growing again. So if you're on that frequent cut, you're doing a frequent cut and you want to optimize your quality, you're better off going down the bale route or cutting and making a compromise most of your fields in one go when there might be variability in the heading date of each field.
Okay, thank you. We are in the east on sandy lands with generally thinner crops. Would you still advise tedding when yields are lower?
No, it's hitting that target. I mean, yes, I'd ted every time if you could then pick up immediately and you were at your ideal dry matter, but it's about that dry matter, hitting that dry matter. And if you go over 32, 33 and your clamp management's not perfect, you will have many more problems. So if the only way you can manage that is by having a thick swath and picking it up a few hours later to get to that 30% dry matter, then you have to do it.
Okay. What is the best way to apply weight on the top sheet? Most of us use tyres, and other options such as mats seem quite expensive. But do you have any other ideas?
If it's an indoor clamp, then straw bales, providing it's not whole crop or maize, because it's a good home for rats and feed just below it. If it's an outdoor clamp, in some countries they actually put round bale silage on it. I've seen that in the UK as well. The more top weight you can put on, the better. I like the mats. They're an investment, a long-term investment, but they do a better job than tyres. The green mesh works, providing you use it correctly. And to use it correctly, you need to finish your clamp in a dome shape, and you need to have sandbags touching all the way down the side, and you need to pull them tight every day for the first week, because that keeps the tautness on the clamp and keeps the pressure on. If you fill it flat or without that dome and you don't tighten it up, then you need as much top weight. Tyres are good, but they're not the best.
Okay. How many layers of wrap do you recommend on round bale silage?
Ideally 6 layers of wrap, particularly if you're using a combi bale wrapper or you're wrapping in the field, because the wrap tends to get damaged during that moving process, even when it drops onto the stubble. If you're wrapping at the stacking site, then there is a possibility within the bulk of that stack, if it's a big stack, that you could actually use 4 layers within the stack because you've got bale on bale, providing you're handling carefully, but around the edges, again, I'd go back up to 6. Again, there's a lot of work from Aberystwyth and from Chagusc in Ireland showing that 6 layers of wrap is better than 4 layers of wrap under UK conditions.
Okay. We make baled silage, usually taking 4 cuts a season. The early cuts have so much water in them in early May, even when we ted 2 or 3 times, and we struggle to bale in less than 2 days. Would we be better to allow the crop to mature more, so as being able to bale sooner? And that is, we are growing red clover with hybrid ryegrass ley to try and reduce the nitrogen input?
That's an interesting question. No, I would probably wilt for longer than trying to make it more mature, unless, I suppose that first cut you've actually got more grass in that sward. So if you've got stock that will that you can feed the poorer quality to, yes, I would probably cut later, thinking about it logically.
Okay, and then the same person has asked, does that ley still require some nitrogen, or could they go completely nitrogen free?
So I'm expecting some feedback on my answer to this one, because some people disagree with me. I personally think that you can get away with very little nitrogen application on that first cut and none on any subsequent cuts. The first cut might need a little bit because your clover is generally slower to get going in the spring, so generally you need fertiliser nitrogen at that point. I've been on farms where they've done a comparison, not in this country, of clover swards, clover-rich swards with and without nitrogen, and their clover-rich swards with nitrogen have lower crude protein contents than their clover swards without nitrogen. I can't say what the yield was, but when you put nitrogen on a clover sward, you tend to switch off the root nodules. But some people will argue that early spring growth needs some nitrogen even on that mixed sward.
Okay, thank you. What are your thoughts on putting slurry onto silage crops and its role in spoiling? We have been tending to put more slurry on than ever before, and over the past few years have noticed a much reduced silage quality, and we wonder if this might be the slurry.
Yeah, the slurry, if it's going surface spread, or if it's not going right down at that root or soil surface, then you are contaminating the crop. And I did some work many years ago, and we found that surface spread slurry, you can still get Clostridia coming through from the slurry even 8 weeks after you spread the slurry. So it increases the risk, and we just have to manage that slurry application in a different way. When I did the trials, we didn't, or injection was a new thing. I think injection is not a problem. It's where you're putting it on the surface and you've got this risk of slurry coming through. And again, maybe because you've increased your rates of slurry application, are you monitoring the nitrogen content of that slurry? And are you actually looking at the nitrate N in your crop pre-harvest? Are you oversupplying nitrogen to the crop? And that's why you're getting your poorer fermentation, because you're over the recommended maximum level of nitrate N. So it could be Clostridia, or it could be oversupply of nitrogen into the grass.
Okay, thank you. What is the ideal machine type for unloading silage into a clamp to produce the perfect clamp face? Do you have any recommendations on type?
No, I don't. You need to keep that face sharp and clean. So, but you know, there's various machines that can do that. The more like a wall it is, the better, because when you get disruption of that clamp face, pulling from it because your tines aren't sharp and your shear grab's not sharp, means that you've got a much bigger surface area, and that surface area to volume in the feed out face allows more oxygen in. So it's all about keeping it very tight and very clean, but there are many different tools and many different operators of tools that can manage that process. I don't like buckets, but some people can even manage it with a bucket. Okay.
Can a microwave be used to determine the dry matter on a total mix ration for a dairy farm, calculating quantities on a weekly basis?
Yes, it can. The microwave will slightly overestimate the dry matter because you lose the volatile acids. So any acetic acid will be the main one. Acetic, butyric, and ammonia will be volatilized in the microwave. So you might be slightly out by 1 or 2%, but that's all. And the wetter your silage, the more you'll be out. But it's a very good process, very easy to use. And I know farms, big farms, that use it on a daily basis to monitor their dry matter going into the ration.
Okay, lovely. Just a couple more questions and then we'll finish up because of time. I think you might have actually already covered this one, but to make silage for dairy cows with the highest possible ME, what should we look for to decide on when to cut and how long to wilt for?
Right, so cutting is relatively easy. I personally don't think you need a silage analysis to do this, or a grass analysis. If there's no seed stem in that crop, then it'll be up at your 12.5 MEs. If you start to see the seed stem emerging, then your ME is dropping. At 11 ME, you will have some seed stem in there. Not much, but a little bit. And as that seed stem elongates and head is produced, then that's dropping further. The dry matter, in that lush green crop, it's likely to be 16% dry matter in the field, unless you're in a dry region where it might be as high as 18%. But the dry matter in the field isn't so much related to what your dry matter of your silage will be. That's your wilting time. And if you're cutting that lush green crop, then you'll have a lower yield in that cut. So your wilting time can be shortened to get to the ideal dry matter.
Okay, are there advantages of using a forage box versus a forage harvester?
No, there are disadvantages potentially. The forage box needs to be managed in a particular way, and often, and not always, I see a problem with silage density because farmers have used the forage box for a low input silage system. And so they cut the sward, they leave it in their rows, they don't ted it out, they don't spread it out, and then they pull 2 or 3 rows into one, and that grass has fallen on the ground perpendicularly. When the forage wagon comes along, it picks it up, and that grass is hitting the knives perpendicularly, so it's traveling straight through without being chopped. The forage wagon should be, the knives should be sharpened twice a day, because they blunt, well, all knives blunt when you're dealing with that much forage. And so you must move the crop, spread it, and pull it back in to get more of the forage hitting the knives perpendicularly, so that they're getting chopped through the knives. And there's no reason why you can't get a 2.5 inch chop length on forage wagon silage. The other thing is that you need to make sure you do hit that 15 centimetre layer depth when you're filling the clamp. Now, if you go back over the presentation at your leisure, Farm 1 was a forage wagon silage. There were 2 or 3 other forage wagon silages in there, but Farm 1, in my view, was first or second in terms of density. So it shows if you have attention to detail, you can manage that forage wagon silage. But if you take your eye off the ball with the forage wagon, it can be a disaster, because long chop, and also if you have higher dry matter, that can be difficult to consolidate, and you have poorer fermentation and poorer aerobic stability.
Okay, lovely, thank you. And then the last question, would you recommend using a high sugar grass variety for improved silage production?
I would, because there's been a significant amount of research over the whole of Europe looking at high sugar grass. And it's not about high sugar for the silage fermentation, because we know we can control the fermentation even with that lower sugar. But if you look at the data from the States now, they're saying the high producing cow needs 1.2 kilos of sugar in the ration every day. What better way to put it in the ration than using a high sugar grass rather than something out of a bag? The high sugar enables us to maintain higher sugar content in that grass silage, providing we look after that preservation process and don't waste it during the silage preservation process.
Okay, brilliant. Thank you very much, Dave. Thank you for that presentation, and thank you to everybody for listening. We've had some great questions there and loads of engagement. I'd just like to remind you that the presentation has been recorded and it will be available on the AHDB YouTube channels along with our other previous webinars should you want to revisit it. Thanks again. Have a good evening, everybody.